Hey everybody, today's lesson is 1.4, Solving Quadratic Equations, Day 2. So we started this section yesterday and we're going to finish it today, and I want to remind you of the two things that we learned yesterday. So yesterday what we had is we had all these quadratic equations and we learned two different ways to solve them. One of them is to factor it, and keep in mind that you can't always factor stuff. So factor it if possible. That's definitely one of the easiest ways to solve. But then remember number 2, the quadratic formula, that negative b plus or minus the square root of all that stuff. Quadratic formula is what you use if it doesn't factor, and that will always be able to solve the problem. And so today we're going to learn two more, what's called the square root property and completing the square. And so hopefully, I think in the past you've probably seen the square root property before, and you've probably solved equations by square rooting both sides. What you're going to use that for is when there is only a quantity squared, which means something in parentheses squared, that's what that means, or just an x squared. So that's going to look like these examples down here, this one, etc. There's only a quantity squared and there's no x term. And so all you're going to do is isolate the squared term. But the most important part is that a lot of times when we square root both sides, we forget this thing called the plus or minus. And so that's one thing that we can't forget when we're doing these. But these are actually pretty simple problems as well. And you're going to use the square root property when there's no x term. Again, so use this property when there's only a quantity squared or an x squared. Like this one, there's an x squared, and there's no x term. And so in that case, what I'm going to do is the easiest way to solve this equation would be to use the square root property. So what I'm going to do at first is to add the 4 to both sides. And that's going to give me 9x squared equals 12. And then don't square root yet, because the 12 is going to be a radical. It's not going to break down completely. And we haven't had the x squared by itself yet. Let's still try and get the x squared by itself. You want to get x squared all alone. And 12 over 9, those both divide by 3. So we can divide by 4 over 3 is what that fraction reduces to. And now what we're going to do is square root both sides. And when you square root both sides, that gives you just an x on the left, but you can't forget your plus or minus here. I'm going to circle it, because whenever you square root a number on each side of the equation, you need to have that plus or minus symbol. So when I square root the 4 and square root the 3, that gives me 2 over radical 3 with my plus or minus in front. And we should probably rationalize that, because remember we can't leave radicals in the denominator. So I'm going to multiply top and bottom by radical 3. And that's going to give me plus or minus 2 radical 3 over 3. And so one more thing that I want to remind you of, something that we talked about briefly yesterday, is that remember how whenever there's a degree 2, that means that I'm supposed to, after I'm done solving this, have 2 solutions to my problem, or 2 answers. And so because of the plus or minus, that does mean that I have 2 answers. And so that's why the plus or minus is really important, because if I plug in 2 radical 3 over 3 to that equation, I get 8. And if I also plug in negative 2 radical 3 over 3, I also get 8. So there are 2 solutions that make this equation true. That's important that we don't forget that plus or minus. Okay, second one, again, we have a quantity squared in this case, so the easiest thing to do would be to, first of all, divide both sides by 3 so that I can get the quantity that's squared all by itself. And so now from here, what I'm going to do is just square root both sides. And so I'm left there with x plus 3 on the left, and don't forget your plus or minus on the right. So anytime you square root both sides, your whole number needs that plus or minus with it. So now all I have to do is subtract the 3 from both sides, and I'm going to write it before the plus or minus. And so what that means is I do have 2 answers here, again with the plus or minus, and what this means is that one answer is negative 3 plus radical 5, and one answer is negative 3 minus radical 5. So that's what that means. You don't have to separate them out like that. In Math Excel, when you're doing your homework, I don't think there's a plus or minus button, and so in that case you would have to write it separately like that, which is a little bit annoying, but just keep in mind that we should always still have 2 answers here, because this is degree 2. We should have 2 answers when we're finished. Okay? Let's go to the next one. So here again we have a quantity squared, and what we want to do is get the quantity that's squared all by itself first. So I'm going to start by subtracting 14 from both sides. That gives me 4 times the quantity x plus 3 squared and negative 16. And now again I'm going to divide both sides by 4. So that's going to give me x plus 3 squared equals negative 4. And so from now I have finally gotten the quantity that's squared all by itself. So what I'm going to do is square root both sides. Yes, I am square rooting a negative 4, and that, my friends, is why we know how to deal with imaginary numbers now. That gives me x plus 3 on the right. The square just goes away. And when I simplify radical negative 4, don't forget the plus or minus, but that actually gives you 2i. So my two different answers after I subtract the 3 from both sides, that's going to give me negative 3 plus or minus 2i. So again, what this means is that x equals negative 3 plus 2i or x equals negative 3 minus 2i. Those are my two different answers because this is a degree 2 equation. Looks like that's the last one from that section. What I'm going to do for the completing the square problems, because these are kind of challenging, I want to do this really basic one together on this video to see if you can kind of get the hang of it. But from there, what we're going to do is I'm going to do the next two in class together because it's a little bit of a trickier subject. So solving by completing the square. What I'm going to do first is fill in these steps, and I'll have you copy them down, and then we will apply each of those steps to problem number 1. Alright, so I wrote down all of the steps for these completing the square problems, and just copy them down, and what I'm going to do tomorrow is write them on the board so that we can refer to them each step that we do, because these completing the square problems actually have a lot of steps, and they're kind of long problems, so they're not going to make much sense unless we're actually doing a problem together. So pause the video and get these copied down, and what I'm going to do is refer to them as we are going through this first example, which is more basic. The other two are a little bit harder. Okay, so the first thing what we're going to do, it says to move the constant over, so that means that 17 needs to get moved over to the other side. That would be step 1, is to move this over, get it out of the way pretty much, which is different from like if you're factoring, doing quadratic formula, doing square root property. So this is a different very first step, but the first thing I'm going to do is get that 17 over to the other side. So I have x squared plus 8x equals negative 17 when you move it over to the other side. Okay, so step 2 says to factor out the lead coefficient. So that would be if there's a number here with x, that needs to be factored out of this left-hand side. And we'll talk more about that tomorrow, but in this case, there is no lead coefficient. It's just a 1, therefore nothing needs to be factored out. So I'm going to skip step 2 just because that doesn't apply to this question. So now the step 3 that I wrote over there is actually to add a blank to each side, and I actually do write this just to keep my work really organized and nice and neat. So I have x squared plus 8x plus something equals negative 17 plus something. So the reason why you need a blank on each side is because we are going to add a number to this equation, and whatever you do to one side of the equation you also have to do to the other. Otherwise, you've changed the equation. So in order to keep it balanced, we're going to add a number onto the left, and that same number gets added onto the right. Okay, so here's the actual part of completing the square. So what we're going to do is I want to look at this 8, and it could be a positive number or a negative number. In this case, it's positive, but we will do examples where they're negative. I want you to take half of 8, which is 4, and then square that number, which is 16. And so I'm actually putting a 16 in both sides of my equation. So that's what half of the x term squared means that I wrote down on step number 4 on our list. You're always going to take half of that number that's with x and then square it, and that's called completing the square. And look what the cool thing is when you do that, when you figure out what that number is, this left-hand side should factor into something squared. And that's the whole purpose of completing the square. And then I'll just combine like terms on the right. Negative 17 plus 16 is negative 1. And so can you factor x squared plus 8x plus 16? I believe it is x plus 4 and x plus 4. So therefore I'm just going to write it as x plus 4 squared. So all we're doing here is factoring this. And if you have completed the square right, it will always end up something squared. That's the whole purpose of completing the square, is to factor that. Okay, and also another cool thing is that once we do harder examples, the way that it factors, if you're having trouble with factoring or if you're not very good at it, it's always that number. It's the number before you squared it. Just as an FYI, this was an easy example to factor, but there will be harder ones that we will do. So it's always that number that goes in the factoring part. Okay, so step 6 just says that now we're supposed to solve this thing by the square root property, which is what we just practiced. So what I'm going to do is square root both sides. Square root. That leaves me with x plus 4 on this side. Don't forget the plus or minus because we still need 2 answers for this problem because it's still a degree 2. And remember when you square root -1, the I comes out and the square root of 1 is 1, so it's just plus or minus I. That means that my answer for x is, when I subtract the 4 over, it's a -4 plus or minus I. So just to recap what I've done, my step 1 was to move this over. The step 2 that you have written down in your box is to factor out whatever coefficient is with x squared, and in this case it did not apply, but sneak peek over here, in this case it will apply. So just kind of keep that in mind that we will talk about that tomorrow in class. Step 3 was to physically add a blank to each side. And so what number goes in the blank is half of this number squared. So 4 squared is 16, and that will be the same number on this side because we added 16 to the left, we have to add 16 to the right. The next step is to factor this whole part, and that will always factor into something squared. That's why it's called completing the square. So that's the important part of that, is that the whole purpose of doing this is so that it factors nicely so that I can then square root both sides. And of course, combine like terms over here on the right, that gives you -1. When you square root both sides, we have x plus 4 and just plus or minus I over here. Last step is to get x by itself by moving over the 4, which makes it negative, and then plus or minus I. So whatever questions you have, we will talk more about this in class tomorrow, but thank you for watching. Bring your questions to class and have a good rest of the night, okay?